This is where we left off at the end of class. We were solving this tan equation. It can't be factored. We had to use the quadratic formula. And we were just in the process of simplifying our quadratic formula. Process of crying. So then,
If this was non-calculator, would we just have to estimate the root? Or would this never be non-calculator?
this would always be a calculator question, because solving for an angle, the only time solving for an angle is non-calculator if it's on the unit circle. Does anybody recognize negative 3 plus root 37 over 2 as something that was on your unit circle? Wow, then you'd made your unit circle incorrectly. No, this is not on our unit circle. And what the plus or minus means is there's one answer for tan theta that is with the plus sign, and there's one answer for tan theta that's with the minus sign. And even though these numbers aren't nice at this point, this is the same as solving like you did in grade 11. We just have a not very nice value on the right-hand side. But what do I need to do next? I need to find my reference angle. Careful here, because when finding the reference angle, we always do tan inverse of the positive value. Question, is that positive or is that negative? A little bit of mental math. It's positive. So in this case, and what you might do is type in negative 3 plus the square root of 37 all over 2 just to check, is that positive or is that negative? In this case, it's positive. So if I want to find my reference angle, I can go tan inverse of that answer. And I find my reference angle, I'm in degrees. Great. Mode, radians. Did I?
Wait, so because it didn't specify degree, we know it's radians?
Anytime that they're asking you to solve for theta and they don't specify, we're going to assume it's in radians, yes.
So 1.54 is the value of theta and then 57?
No, 1.54 is the ratio. That's what the negative 3 plus root 37 over 2 is equal to. And I want to do tan inverse of that number.
Can you do tan theta and then the equation?
So there's my reference angle, 0.995. So when I write this out on this side, it will be 0.995. Because this is positive, I would be looking in quadrant 1 for tan and quadrant 3 for tan. Does that make sense? So my actual answers on this side will be theta is equal to 0.995, comma, that'll be my one answer. My second answer would be in quadrant 3, so I'd go pi plus my reference angle, 4.14. That solved between 0 and 2 pi for one of the ratios. I also need to solve between 0 and 2 pi for my other ratio. So here, when I type this into my calculator, maybe you can tell already that it will be negative, but I will test it anyways. when I type in negative 3 minus root 37, I get negative 4.54. And if you feel more comfortable with that as far as your work, right, you can do that. And then we need to find our reference angle. How am I going to find my reference angle? I'm going to do tan inverse of the positive value. How can I type that into my calculator quickly? Well, I can go tan inverse. I want to use my answer, but my answer is negative. Can you see that you could go negative answer to make it positive? Does that make sense mathematically? If my answer is negative and I multiply it by -1, that would make it positive. And my reference angle this time is 1.35. Which quadrants is it going to be in this time? This is negative, so it'll be in quadrants 2 and quadrant 4.
What was the actual number from the other one?
The actual,
Before the reference angle, like tan theta was what?
we can go up and take a peek. I do have a class. 1.54. What I'm going to do right now is I have that 1.35. That was my reference angle. I know that I have to do two calculations with that because I need to find the angle in quadrant 2 and the angle in quadrant 4. So I'm going to store that value above your on button. I'm going to store it as x. I like using x because it's the quickest button to choose. And so now when I want to find the actual angle in quadrant 2, I can do pi minus x, or pi minus my reference angle, 1.79. And when I want to find my answer in quadrant 4, I can go 2 pi minus my reference angle, which is x, 4.93. I guess technically I should have approximation signs here. Yes?
Why is it okay, like on your calculator, you put the negative ratio in? Why is it okay now? Like, if you look at it.
What I actually did here, in this step right here, I put in tan inverse of positive 4.54. If we look back at our calculator, the reason we can see that is I have tan inverse negative my answer. And since my answer was negative, putting an extra negative in front would make it positive.
Why isn't it not the same for the other calculator? Like if you have like -1/5, you would just do tan inverse 1/5.
That's right. You always do. It is actually the same. Because so you're saying if I had tan theta equals -1/5, okay, this is what I typed in. Tan inverse of negative, and then what happens if I do that? Negative -1/5. It makes it positive. So since I had an answer that was negative, I put a negative in front to make it positive. Does that make sense? And this, although when you're typing this in, you would never do that. That's a whole bunch of extra negatives you would write. You know just to change it to positive 1/5. But in this case, because I didn't want to, let's go back up here, like that's the number that I had. I didn't want to retype 4.541381265. Okay? I mean, you could have taken this number. Oh, shoot. Clear. So there's different ways you can go about this. If you wanted to, I'm going to take this number and say, I have this number. I could multiply it by a -1 to make it positive, And then I could go tan inverse of my answer if you feel better working that way. Same reference angle. But we do always do, for our reference angle, tan inverse of the positive value, because a reference angle is between 0 and 90 degrees. And we're imagining we have that actual triangle drawn with our reference angle where all the side lengths are positive. So now we have solved between 0 and 2 pi. How do we write our general solution? Step 2 for general solutions. You list all of your answers, 0.995, 1.79. They do not have to be in order, but maybe you're a little bit OCD like me and like them in order. Yes?
So you could, before did you say you could just write like one of the numbers and then put like plus k pi?
It depends where they are. Okay? For tan, that would work because an understanding of tan, where's 1.79? Right here. Where's 4.93? Exactly 180 degrees around there. That's not easy to see. So the recommendation is just, once you find them, just list them all and go plus 2k pi. Because the plus k pi only works with tan. And then understanding why it works, you're probably safer just going plus 2k pi. Yeah, and generally with the multiple choice and knowing the plus k pi, so I could have combined this one and this one together, and I could have combined this one and this one together. Chances are in a multiple choice, they would only do it with values from your pi plate, so it's easier to see. I would write 0.995 plus k pi. Because halfway around, like if you add 3.14 to this, you will get 4.14. Okay? And you probably, can you see this is really close to 1 if I round? And if I round pi really close to 3.14, 1 plus really close to 1 plus really close to 3.14 should get you really close to 4.14. And I could have combined these blue ones by doing 1.79 plus k pi. And I would only need to write them once. But you're not deducted for writing extra answers down. So when solving the general solution, to recap, okay? The general solution, you solve like normal from 0 to 2 pi. Sometimes that means you use your unit circle because you know the reference angle and you don't need your calculator. Sometimes you need to find your reference angle and use the cast rule to find out what quadrants it's in. Once you've solved from 0 to 2 pi, all the general solution says is you're going to have to add 2k pi, because then you'll list every single coterminal angle with that angle forever. And then you have solved for the entire general solution. Of course, what can happen? Well, we could get questions where you have to use your quadratic formula. 4 years ago, the quadratic formula wasn't on your formula sheet. But they really wanted to ask these questions. And so people thought it was not fair because a lot of you had forgotten your quadratic formula from grade 11. So they said, well, let's put the quadratic formula back on. And then they started asking these questions a lot. You can take the formula sheet off again. You wouldn't mind? All right. Questions for practice on this one are 5, 6, and 9.